Hi, everybody. Thank you for joining us today. We're going to be talking about a challenge that I think almost every IBM team deals with at some point of time, which is planned downtime. Whether it's backups, upgrades, maintenance, or even migrations, these are things that the business knows has to happen, but they still create disruption, risk, and get you in a line of cost. So what we want to show you today is that downtime doesn't have to be accepted as a price of keeping systems current. And there are practical ways to reduce it and in many cases eliminate the business impact altogether. My name is Haley Vyas. I'm a product marketing manager here at Precisely, and I'm joined by my product manager, Dan Sims. Before we go ahead, a few housekeeping items for us. This webinar is coming to you live, so if you face any visual or audio issues, please feel free to use the Q&A box to the right of your screen. Once you put in a message, someone from our team will be in touch with you and will help you troubleshoot. The webinar is also being recorded, so please don't feel the need to take notes down. You will receive a copy of the recording and the deck in your inbox once the presentation is over. And at any point during the presentation, please feel free to use that same Q&A box to put in questions. We do have some time at the back for questions, so we try to get through as many as we can in the time duration, but if we can't, we will reach back out via email. So with that being said, let me show you a little bit about what we're going to do today. It's pretty simple. I'll start by setting the stage with the impact that downtime has on the business and why this matters more than ever, super short. And then I'll hand it over to Dan and he'll take us on to the practical side of things, how to minimize downtime across a range of common IBMI activities. And then we'll wrap up with some Q&A. So going right into it, let's start with the business side of things. When we talk about downtime, there are really two categories, right? Planned downtime is the one that we schedule, things like upgrades, maintenance, or even like just configuration changes. Unplanned downtime is what catches us off guard. It's failures, outages, or even other disruptions that we didn't anticipate. And while these two types of downtime are obviously different, they create the same basic problem for businesses. Systems aren't available, people can't work, and revenue, operations, customer experience, all of this starts taking a hit. The most important point here is that just because downtime is planned doesn't mean it's fully harmless. It may be expected, but it's still disrupted. And in many organizations, it's still treated as unavoidable. So now here's the challenge that we see in a lot of organizations. There's a constant tension between IT and business teams around downtime, right? And what often happens is planned downtime gets pushed out. Patches get delayed, upgrades get postponed, and maintenance gets squeezed into smaller and smaller and smaller windows. But the reality is that avoiding planned downtime doesn't eliminate the risk. It's kind of actually increasing it because planned downtime is controlled, it's predictable, and we can decide when it happens. But unplanned downtime is the opposite. It happens when you're least prepared for it, and it's almost always more disruptive. It introduces unexpected disruptions to the business, longer recovery time, and typically a much, much bigger operational and financial impact. So the goal here isn't just to reduce downtime, but it's to eliminate the impact of it altogether. And the reason this matters so much is the reason this matters so much now is that the cost of downtime has gone up and very significantly. What used to be viewed as an operational inconvenience is now a much bigger business issue. The financial impact is real, as we're seeing around $24,000 a minute as the average cost of IT downtime for enterprises. That's significant. The recovery burden is real. We're seeing 67 to 76 hours average recovery time. And in so many cases, there are regulatory and reputational consequences layered on top of this. So this isn't just about a short-term interruption anymore. Downtime can trigger a chain reaction. We're seeing lost revenue, we're seeing long recovery windows, potential fines, and even damage to customer trust. And once that trust is impacted, we all know it's much harder and much more expensive to win it back. That's why organizations are rethinking the old assumption that downtime is simply just a part of the job. More and more expectation is, how do we keep the business running while these necessary activities still happen? And so this is where downtime becomes much more than just an IT issue. So yes, like as we saw, there is an obvious direct revenue loss if systems are unavailable. But that's just one piece of the big picture. Downtime affects employee productivity because people can't do their jobs when core systems are unavailable. It creates hidden costs. We see overtime, extra recovery effort, shipping delays, temporary workarounds, even legal or contractual exposure in some cases. And then, of course, there's a reputational side, right? We've got frustrated customers, disrupted partners, and a hit to that trust that can carry forward long after the outage itself is over. So, when we talk with customers, we see one of the most important questions to ask is, do you actually know your cost of downtime? Not just in like the abstract, but per hour, per event, or per business process. Because once you understand that, it becomes a little easier to justify a different approach. And that really brings us to the heart of today's discussion, that if downtime is this expensive and disruptive, what can we do to eliminate the impact of planned downtime you still need to perform efficiently? And this is where I will hand it over to Dan to take you through how we can start to do this.
Thank you very much, Haley. And thank you all for listening today. And my name is Dan Sims. I'm the product manager here at Precisely for the IBM HA Solutions. And so what I'd like to do is take you through some of the top techniques and solutions to uh, solving some of these planned downtime issues that Haley just mentioned. And here at Precisely, our business is dedicated to giving you IBM iShops options to manage risk and downtime. So that's what we do. That's what we wake up in the morning thinking about. And so I hope these are helpful to you. So the first one is the backup while active. And this one is tried and true. We have customers doing this all over the place. It's a great solution and it's pretty simple. So when it comes to just getting a backup done, you run into some challenges. But one thing before I get into some of the challenges is you might say, well, gee, I have an HA solution, so why do I need a backup? Everybody needs a backup. I don't care if you're running an HA solution or not. Flash copy, Power HA, logical replication, Mimics, Itera, everybody needs a backup. So just keep that in mind. Now, some of the challenges that come in with trying to get a backup. What's really happening on production system is you run into locked objects, right? Now, if you can bring the application down at night and get all the users off and quiesce everything, you don't have so many challenges. But as this, you know, some of those downtime windows are a bygone thing. They're just not available to us anymore. So the application runs 24/7 and you're going to run into locked objects. Your application might be using open commit control cycles. You'll run into them. Um, and just generally running backups on this production system can be disruptive. So you might not be able to get a backup, period. And if you are in the process of doing a backup, like a save, your application might have some contention while it's trying to address an object, but the object is currently being backed up. So these are things that can be avoided with backup while active. So the essence of it is, and this is why I say it's simple, is do your backups on your save operations on a backup system, right? So instead of doing it over here on the production system, do it over here on the backup system. And so you have a full copy of the database there. It's in sync with production through Mimix replication or ITERA or QuickEDD replication. And you can then perform a backup. You can do it with traditional magnetic tape, or you can do it with virtual tape libraries. Doesn't matter what the technology to do the backup is. The key is that you have this real-time replication which can be paused. And by pausing it, you no longer are subject to all those locks and all those commitment control cycles, and your application is over here running happily without any disruption, and you're doing the tape over here, right? So great solution. People do it all the time. Now, one thing that I'll point out a few caveat important things here is that we have remote journaling staging of your changes on the backup system while the tape is spinning. So you're still protected. Your RPO is still intact there. So that's important. And then the other thing is you can take advantage of things like flash copy or save while active on the target system. So you don't need to leave your applies down for very long at all while you're doing the backup. So lots you can do there. Here's a step through target side backups are a proven and reliable solution. We have this running at all over the place. Thousands of LPARs are doing this. Simply end and apply side replication to establish a known save point. RPO is maintained. You can use save while active, enables target flash copy as well. So, by the way, when you do this with Mimix or ITER QuickEDD, you make flash copy way better, right? Because if you've ever tried flash copy, you run into things like dirty flash copies, and when that's what happens when you try to flash an active LPAR, is you get a dirty flash copy, and when you try to IPL that LPAR, it may not. So with this solution, you can get rid of all those commitment controls easy, flush everything to disk easy, release all the locks easy, do your flash copy. Now you got a high quality snapshot, and you can use that. So take advantage of it. Let's move on to the next one here. And this is one of my very favorites. And we actually had a customer who had a OS upgrade failure recently, and they needed to take advantage of their Mimix implementation to um, abort mission, right, and keep the business running. So these things happen, and when bad stuff happens, if you ever study accidents or things that break down, it's not one thing. It's often a series of things that occur to start a chain reaction that ends up having a breakdown, and that's kind of what happens when the OS upgrades fail, and so you need to protect against that. And so the most important thing is to recognize that a new operating system incurs a heightened risk, right? So usually they're routine, but when they don't work, then what are you going to do? So you must have a go back option when you do OS upgrades. So for example, if you're on 7.5 and you're going to go to 7.6, you have to have an option to get back to 7.5 if your application doesn't run on 7.6. And it probably will run. You've tested it. Hopefully you've tested it, right? You've done your diligence. But the ones who have OS failures have done that too. And you're making a material change to your application, and it might not work out for you. It's very hard to test these under real world workloads. Um, and so you don't test it just like your production system is. It's sometimes impossible to do that. So you solve that, you mitigate that risk with a go back option. So the go back or this approach also includes burn-in time. So you get to upgrade the alternate system while you're still running production on the old. So let's take a look at this one a little bit closer. So here we go. Let's start with number one. So we're going to assume that we have a production and a target server replicating, I'm going to say with Assure Mimics today. Okay. So you are in sync and you are switch ready. So the first thing you're going to do, and I'll say, stay with my example. This one's at 7.5 and this one's at 7.5, right? So you're going to go ahead and upgrade this one to 7.6. All right. And you're going to run a week there. So you're going 5 to 6, lower to higher for a week. Okay. So let's go to number two. So actually, after that week, then you'll schedule a planned switch. So you'll do a controlled shutdown on the production and you'll come up on the target. Okay. So now you're on production here. Now you're going to come over here. You can sit there and run a week. You should. You should run another week. So run a week on this server and you're going higher to lower. So you're going 7.6 to 7.5, and that's okay to do. And we support that, by the way. Just make sure you don't upgrade your application to features that are only available on 7.6. That wouldn't be good. So just chill, right? And run your application, run the business for a week, and now you go ahead and you upgrade this box. So now you're at 7.6 and 7.6. And so what if the what if you found out when you upgraded this target server and switched to it that your application wasn't going to run? Well, that's when you're going to run a week there. So you still have this production server at 7.5. You can simply shut down the application on the 7.6 node and do a controlled switch over to the 7.5 node. And remember, you have Mimics replication in there, so that's replicating the data back. So you're not losing any transactions or anything like that. And if an OS upgrade fail, the way often we see it happening is that you do get to the new system and you do run application there and it's not running well. It's running so poorly that you have, and sometimes it takes a while. Maybe you upgrade the system on Sunday or Saturday, and on Monday, when everybody comes into work, that's when it starts running poorly. So this is that those are realistic scenarios, right? So you need to think about it in those terms. You have a go back option to the lower OS, you go back to the safe harbor, and a place where you know you can run. Now, I do mention here the secondary target. So anytime you have an additional node, you have advantages there, right? So in this case, for example, while you're upgrading this target server, that secondary target acts as an alternate failover option. You can also do things like say, well, I always have to have two, right? I could say, well, I have to have two 7.5s and one 7.6. Or I could, once I get to 7.6, I could say, well, I got to have two 7.6s. So you could upgrade this one, leave that one at 7.5 and stuff like that. So you can manage it that way with a secondary target. Of course, we support 3 targets as well. You might have this set of LPARs at one data center, and then you have this set of LPARs at another data center. So those are all options that can help you manage this OS downtime issue. All right, so we've done a few webinars, quite a few on migrations. So hopefully you get a chance to listen to those. We talk about migrating to the cloud and things like that. But really what a migration is just moving from one operating environment to another. And I always talk about being careful about limiting your variables, right? So I just got done talking about OS upgrades, right? That's a variable. Um, new hardware is another variable. Network infrastructure, data centers, um, all those things. And then there's, of course, maybe application changes, right? So the fewer things that you can change during a migration, the better. Um, so, but you can manage some of these. Like you could combine an OS upgrade with a migration to new hardware. It can and it is done. You just have to be aware that that's a more change. So take that into account. But migrations with our solutions help you again to uh, manage the risk of downtime and allow you to practice it, right? That's really it. So you can set up a migration target system and test it all out. And even better would be to set that LPAR up ahead of time and before you even turn on replication and burn it in and make sure that you're happy with the way it runs and then turn on replication. And then you position yourself for minimum downtime at cutover. So let's break this one down a little bit more. How does it work? So logical replication, if you're using Quick EDD or ITERA or Mimics, enables a synchronized pre-production migration target. Okay, so you have a target system that is at the ready, it's in sync, right? And our audits will verify the integrity of the target system so that you know you're in sync. And then you can do iterative cutover practice runs. And we encourage you to do that. Do it a few times until all the issues are worked out. Make sure you bring in your UAT personnel. So we also have migration services here at Precisely that's available to help you with this. It's important to have a good migration approach, right? A good approach turns into a good landing, right? Software installation, configuration, sync point, verification testing on a new system, final switch, attending a switch event, and coordination with your staff. So these are services that we can provide, and as well as some of our partners can provide. In terms of testing, test, 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 right? And you, the name of the game here is that you stay letting your application running on production on the old system and you test out the new one. And so, of course, these are the things you're going to do: connectivity and network, security. Make sure to keep security in mind here when you're doing this. Data integrity testing. Now we have our audits. Our audits are going to be able to compare a lot more efficiently than manual testing, but it never hurts to do spot checking, right? And the reason why I say our audits are going to be able to do it better is, don't forget, the database might be changing millions of times an hour or more, tens of millions of times an hour. So our audits know how to deal with that and can ensure data integrity in that kind of changing volume environment. So keep that in mind as well. Application verification and user acceptance, of course, those are important. So migrations, like I said, we cover this a lot in other webinars, and I encourage you to take a look at that. So let's move on to the next one of our favorites here, and that is encrypt while active. So in today's world, we're all more and more security conscious, and there's starting to be regulations and requirements to have data at rest be encrypted. So, but just that's easier said than done, okay? You might have experienced that. There's some challenges to that. You might have a very, very large file that needs to be encrypted. And when you do that, you have to basically take an outage on that file. It needs to be dedicated to the encryption process, and that might be painful. So small files, no big deal. You can do them quickly. But if you got a big monster file with a whole bunch of access paths and things like that, that really might not work out so well for you. And so that really adds a risk of downtime there. Um, so we actually have some options to solve that problem, and we call it encrypt while active. And we have something in our software, the Mimic software, called Mimics Promoter, and the function is called copy active file. And so by combining the copy active file capability with the encryption, you can do an encrypt while active. And so the way it works is you create a pre-production copy of your encrypted data. That is going to be empty. The file is going to be empty. And then you would go ahead and copy the data over from the production file to the empty encrypted file. And each record that gets added to that empty file, the temporary file, gets encrypted as it gets written. And so you're happily running over on production. Your application is just running normal. And at the same time, you're encrypting your data in this temporary file. And so once that's done, then you schedule a small outage and you would then just do some move operation. So you would move the production file into an archive library, and then you would move the temporary encrypted file into the production library, and then you can start using it. So that's the approach. It's proven to work well. Um, and like I say, small files you don't necessarily need to do it this way, but the big files you probably do. So we do. We're glad to talk to you about this. We have some solutions and software to help. Like I say, it's called Mimics Promoter, and it works well. And let's move. Here's some benefits for you on Encrypt While Active. Minimizes downtime for encryption operations, mitigates risk of application failure, ensures HADR readiness throughout the encryption process. So this is an important one, right? You don't want to suddenly be non-switch ready. Um, you got your files encrypted, but they're out of sync, right? So you want to keep that in mind too. So we can talk to you about that and how to do that. That's all doable. Mimics will follow the move object as well. Next one is very similar to encrypt while active, compression while active. So instead of doing encryption, we're doing compression of deleted records. Okay, so we're eliminating wasted space. Um, I don't know if you're familiar with deleted records or not, but on a IBM I file, when you do delete a record, you actually the data the record is actually still there. It's just marked as deleted, right? That's done for performance reasons. Some files, um, well, let's just say there's a parameter on the file that you can set that allows you to reuse deleted records, and you should do that, right? So this way, you delete a record, it's marked as deleted, and then when a new record is added, it would go into that deleted record space. That's called a put deleted record, or yeah, put into a deleted record. So it reuses that space, and that's much more efficient. But some applications out there have that set to no. And going back to the early days, that might be going back to the early days. So if you have a whole bunch of deleted records on your file, it may be time to do a reorg. And so there are IBM commands to do reorganize while active. You can do a reorganize, dedicated reorg. You can do a reorganize while active. And so those are fine. You can use those. But sometimes you have files that are just too big and too complex to you be able to use the IBM reorganized PFM tools. So that's where we can come in with that same Mimics promoter that I mentioned, copy active file, take a very similar approach to the encrypt while active. We can do it to compress out the deleted record. So here's a picture of it. We have the production file here, which is replicating to the target. So you have the same deleted records. You can use the copy active file to come down here and compress it. So here we have a much smaller compressed file, which is also being replicated by Mimics. And then when you're ready, you take a short outage and you move this one off to archive. And Mimics, of course, will send that off to archive through the move object. And then we'll move this one into production. And of course, this one gets moved along with it with the move object. So that's a great solution. If you are having trouble with reorganized physical file and you just can't get these reorgs done and you have these big files using up a bunch of space, let us know. We'd be glad to talk to you about compression while active. So here's the benefits of that. Near zero downtime. Switch readiness is maintained through the process. You can do these reorgs during normal business hours without burdening IT teams or business operations over the weekend. And then uh, make sure you have a good plan. It's always on all this stuff. You have to have a good plan so that you can ensure success, right? Because you are operating around the core of these production applications. All right, I've got a few more I'll mention to you that are my favorite things to talk about avoiding downtime. So we've got file upgrade while active, workload distribution, and continuous availability through active-active. So let's start with this file upgrade while active. So just like the encrypt while active and the compress while active, how about file upgrade while active? It's the same thing. We're using Mimics promoter here. Now it's a little bit of a twist. Instead of encrypting or compressing, we're actually um, upgrading the file. So look here, we've got a character 10 going to character 50. We've got a numeric 6 going to a numeric 10. And here we've got an entirely new field being added. And so all this being done on a 1 billion record busy file that is core to the application. So the copy active file uh, keeps this, it will copy it from 0 to 100% and then keep it in sync until you're ready for that short outage window, and then you can promote the file. Just like the other ones, we'll take this one out, that goes to archive, and then this one goes into production, and Mimics will follow all that. So great solution. You have to have a good plan for it, but it will result in reduced downtime for you. All right, that just kind of tells you how it's done, just like it's the same approach as the others, right? Copy the production file to a temporary file, Mimics promoter will keep it in sync until you're ready, and then you do a promotion. And don't forget to keep these files replicated so that you maintain switch readiness at all times. Okay, another one of my favorites, access production data without the impact. So this one is let's move the users. So instead of having the users hitting your mission critical production that's maybe running the production line or running the bank or whatever it is, instead of having, everybody knows that everybody wants to query data, right? They need it now for business intelligence. They need it for AI, right? So do you really want them hitting your primary system? This is an age-old problem and an age-old solution. Very simple. Put them on a reporting server. And so Mimics will replicate to that reporting server real time. And you've just taken a sizable amount of workload off of your production system. And so now you can just focus on making sure the production system is running and its core duties of keeping the application or keeping the production line running. And these people can get their data off here quite happily. So it's really simple, and Mimics will keep that in sync, and it's separate from the production system. So take advantage of that. I always like to remind people we have features in here that you can change the target side files. We call it ignore attributes. So for example, let's say that you have triggers on your files, but you don't need those triggers on the target side. You can remove those triggers and you can tell Mimics to ignore the fact that there's no triggers there. That's ignored attributes. That's a common one. Same referential integrity constraints. You can take those off and tell Mimics to ignore that they're not there. You can tell it to ignore, you can add logical files or remove logical files on this reporting server. Tell Mimics to ignore that it's there. Okay, so that's a good one. And the last one I have is active. So it's right in line with what I was just talking about, where you're going to put users over here on the target. And all there's thousands of people running Mimics, Itera, QuickEDD out there, and every single one of them are operating in a active orientation. Did you ever think of that? You're doing active for read operations. Okay, that's what logical replication is. And so that means that you can look at that target system and use it, and you can run backups on it, and you can run queries against it. Um, and move all of that activity off your production system. That's what makes the solution so great. But in addition to that, you can even do active for write workloads. And this one is less common. There's not that many people who do this, but I think more people kind of wish they could. And so Mimics fully supports active. You do have to have keyed physical files. So you have to be able to identify the records individually, uniquely. And this isn't something that you would roll out across your entire application, but you could definitely have some specific files. Um, and for a specific reason, you could set those up to active. And when you do that, there's no downtime at all. You could put load balancers in there. You could you could shut down one system and have it automatically switch to the other. So there's a lot you can do with this. I just want to make you aware that this is out there, and if you're interested in this, be glad to talk to you about it. And I always like to put this one up and talk about resiliency scores. Um, This is the kind of thing here that really matters when you're talking about resiliency. Okay, these are the things that people need and worry about and matter when you're trying to keep IBMI up. And so if you take a look at this, Mimics always scores at the top. So you're going to get much more value with a logical replication solution than you are with a storage-based replication solution. So keep that in mind as you're making decisions about managing resiliency on IBMI. And if you have any questions about this, please do just let us know. And with that, I think that that's the end of it. So Haley, we're on to
Thanks,
questions.
Dan. Yep, that was awesome. I did see a couple questions coming in, so we have time to do a bunch. So I'll go from the top. One of the first questions was, if I replicate my temp files, will that impact my production data groups, and should I put them in a separate data group?
That's a great question. I think, yes, I think you have reason to ask that question because you might have a very large file and you're going to be copying every single row from the production file to the temp file. And yes, that can potentially overwhelm your production data group. So that's definitely a legitimate question. If you have concerns about that, there's a couple of things I would recommend. So remember, you can put the temporary files on hold. And well, actually, before I answer the question, the reason why you want it in the same data group is so when you're processing the move operation, that it happens seamlessly. In Mimics, if you cross a data group boundary, you might end up having a resync on a large file, and that's something you'd want to avoid. So that's the reason why you want them in the same data group. Now, to alleviate the concern about the high numbers of records being copied, you can put the temporary file on hold ignore. And so then it won't transmit, it won't replicate anything in that case. You could even end journaling on it while you do the copy. And then once you get the copy done, you can actually pause the copy active file, start journaling on it, sync the file. You could sync it through Mimics, or you could through the network, or you could even sync it using a save restore technique. Either one's good. And then after you get the save on it, and you can restart the copy active file. It'll pick right up where it left off, and now it's in sync, and you don't have you're not overwhelming your data group. Now, the other thing to consider as an option is you could use journal-centric replication, which is relatively new with Mimix 10, and we're actually going to be doing additional journal-centric capability in the future. So that's another way to solve this problem. But if you have any questions about that, concerns, or want to discuss your approach, just let me know.
Awesome. Thanks, Dan. The next question is, my save is taking hours. Do I have to leave my data group down the whole time?
Um, no, no, you don't. And I mentioned this earlier. I don't know if you caught it, but the save while active is a great thing that you can use. And a lot of people have tried, they'll say to me, well, save while active doesn't work. Well, the reason why it didn't work is because you did it on the production system. You probably had open commitment control cycles and locks. Then it's not going to work. But if you run a save on the target where you can simply end Mimix or end Itera and release all the locks, there's no commitment control, there's no locks, your save while active is going to work. So the save while active is going to come back to you. It does a checkpoint. It's going to reach that checkpoint very rapidly. As soon as you get that checkpoint, then you can go ahead and restart your applies and you're back in business.
Great. The next question is, can I use this to change the file size of my production table?
Yes. I assume when you say the file size, you're talking about the field sizes, right? You're changing the field sizes, and that would be a file upgrade while active scenario. So yes, you can use the copy active file as part of Mimix Promoter to do that. And we've done that many times. Customers are using that and getting value from it with that very use case. Yes.
Okay. Okay, that makes sense. We'll do one last question. It says, why not just use the IBM reorg command?
Oh, and as I said, please do use the IBM reorg command. It's a fine command. It's got a restart capability, so you can do a reorg while active with it. If it works for you, use it. But sometimes there's files that are just so big and so difficult to work with that that's not going to work. So the compress while active as part of the copy active file and Mimix promoter is a solution to that problem. So when you run Mimix, you have that capability in your back pocket if that ever comes up.
Okay, amazing. Cool. That was all the questions we had, Dan. So thanks for that. Um, Thank you, audience. You've been great. That's all we had for you today. If you have any other questions for us, please feel free to reply to us when you get the follow up with the recording and the deck. And we'll catch you on the next one. Have a good rest of your day.